Hello everyone. The topic for today is prime factorization. Right now I want you to pause the video so that you can take all of your notes and then resume when you're ready. Okay? These first three examples are asking if the number is prime, composite, or neither. So let's look at the number 12. Well, to determine if a number is prime, we have to ask ourselves, does it have more than two factors? If it does, then it is composite. If it has exactly two factors, then it is prime. Well, there are several numbers that will go into 12, such as 1 and 12, 2 and 6, 3 and 4. So since we have more than two factors, 12 is a composite number. Looking at a number such as 51. Well, 51 doesn't have the most common factors. However, 51 is divisible by 3. So, if we were to divide 51 by 3, we get 17. So that means that it has more than two factors. Those two factors would have to be 1 and 51. So 51 is also a composite number. And last we have 11. 11 only has two factors, 1 and 11. There's no other set of whole numbers that we can multiply together to get 11. Therefore, 11 is prime. Now we're moving into prime factorization, and we're going to write the prime factorization of 24 using exponents. And to do that, we're going to do what's called a factor tree. Okay, so we can use any numbers that would multiply together to give us 24. So let's use 4 and 6, for example. You could do 2 and 12. You could do 8 and 3. The only ones that are not allowed are 1 and whatever the number is. So 4 is not a prime number, so we can add more branches, so to speak, to our tree. 6 is also composite, so we can add more branches to our tree. Now we have to do a similar thing with the number 4 and also the number 6. Two numbers that multiply together to get 4 are 2 and 2. Two numbers that multiply together to get 6 are 2 and 3. Now we have to ask ourselves, is 2 a prime number? Now, just as a reminder, prime does not mean odd. Prime and odd are not always the same thing. Okay? So, a perfect example of this, 2 is a prime number, so we're going to circle it every time we see it. 3 is also a prime number. Since we have all prime numbers now, we can write it as a big multiplication problem. 2 times 2 times 2 times 3. So that would be the prime factorization, but remember, we have to use exponents. We have 1, 2, 3 2's, so that would be 2 to the third power, and then we only have 1 3, so times 3. That is the prime factorization of 24. Now let's try to find the prime factorization of 40. So again, we can use any number combination that multiplies together to give us 40. So we'll use 10 and 4. 10 is a composite number, so we can add more branches. 5 and 2 multiply together to get 10. And 5 is a prime number, so we're going to circle it. And as we talked about before, 2 is a prime number, so we're going to circle it as well. Two numbers that multiply together to get 4 are 2 and 2. 2 is a prime number, so we're going to circle it. So as a big multiplication problem, we have 2 times 2 times 2, because we got 1, 2, 3 2's there, and then times 5. Now we have to write this using exponents. There are 3 2's again, so 2 to the third power times 5. That is our prime factorization of 40 using exponents. Last, we have a negative number, and the only difference between a negative number and a positive number for prime factorization is we have to start out our answer with -1 times whatever the prime factorization is. So we're going to treat this just like a regular 50 and do our prime factorization using the factor tree. So 10 times 5 gives us 50. Well, 10 is a composite number, so we can add more branches. 5 times 2 would give us 10. 5 is a prime number. 2 is a prime number. 5 again is a prime number. So we have 5 times 5 times 2 as our long multiplication problem. And to write that as using exponents, it would be 2 times 5 to the second power. So we're going to take this and we're going to put it right in there. So -1 times 2 times 5 to the second power. That is our prime factorization. And I'm going to fix this too, just so that you can see that. So to the second power. So that is our prime factorization of -50 using exponents. If you have any questions, please bring them with you to class. I'll see you later.